Good afternoon and welcome to our GMAT prep session web chat. We appreciate you joining us today. We were starting a little bit late. Sounds like there were some technical difficulties, but I think we're all good and all set up now. So I am with Stephanie Espy, our alum and owner of Math SP, GMAT preparation tutoring service here in the Atlanta area. And we're going to go over some strategies and some sample problems to make sure that you are completely ready for your GMAT test, whether you're taking it for the first time, second time, third time. Stephanie's got some really great insights here. We are focusing solely on the quantitative part of the test, just so you know. So we'll be focusing on the data sufficiency and problem solving. And a little bit of housekeeping before we get started. You can submit any of your questions during the chat into the chat window, and I'll make sure I field them to Stephanie. If I don't field them right away, it's probably because I know she's going to answer that coming up, because I've got the slides and you guys don't. But also, she'll be writing out some of the questions on the screen, so you'll see her work as she does it live. Following the session, we'll make the actual presentation itself and the slides available to you via a link, and we'll email them to all the registrants. So please make sure that you're paying as close attention to what she's doing here and not necessarily worrying about notes, because you'll get copies of the slide portion and video for you to review later if you need to. Keep your questions coming. There are no stupid questions. This is going to be a lot of great information. We're going to pack it into that time. We may go a couple of minutes over just to make sure we compensate for this for the slightly later start. But it'll be a great session for you. So I am going to go ahead and turn it over to Stephanie, who's going to get us started. Stephanie?
Thank you. All right, guys, I hope you all are excited to spend a little bit of time covering the GMAT. I'm excited to be here. I'm actually an alum of the full-time program, finished in 2008 with a MBA from the full-time program. And prior to coming to Emory, I spent a lot of time doing lots of math. So math is one of the areas that I have never stopped doing. So fortunately for me, the GMAT math was something that was familiar. But for a lot of people who haven't, been in school for many years, who maybe the last time you looked at a percent problem or a ratio problem was probably in, your senior year of high school or freshman year of college, there definitely is a little bit of a curve or a lot of catching up to do before you get into the GMAT quantitative section. So we will review some of those key concepts that are tested on the GMAT. The good news is that there is no advanced math, there's no algebra 2, there's no trigonometry, there's no calculus. So really we're looking at your middle school, early high school years of math, all the way up through geometry is the math that you need to know for the GMAT. Just before we get started with some of the problems, if you look at the slide that's labeled the two different question types. We're going to talk about those question types first, and then we'll get into some sample questions. So the first type, if you've been studying for the GMAT, you know these question types by now. The first is the problem solving. We'll call that the PS question type. The problem solving questions will ask you to solve a question, and you'll have 5 different responses. You have to choose the correct response from the 5. And then the second type is very unique to the GMAT. This is called the data sufficiency or DS question type. And these types of questions are going to give you a statement and then 2 different pieces of information. And with those 2 pieces of information, you have to figure out if that's enough to answer the question being asked of you. So statement number 1, is that enough information, yes or no? Statement 2, is that enough information, yes or no? And then choose a corresponding answer choice, and we'll get into those answer choices later on that can help you, that answers the question of, do you have enough information? So that question is all about information, not so much about actually solving and getting to a numerical response like the problem solving questions are. So these question types are test you on the same concepts, but test you on those concepts in a different way, and we'll talk about that later on. From the slide, you also see that there are 37 questions in total on the quant section of the GMAT. You have 75 minutes to complete those 37 questions, so roughly we're looking at about 2 minutes per question if you answer all 37 of them. And roughly about 21 problem solving and about 16 data sufficiency. And as you know, for the GMAT, the questions that appear can be in any order. So your first question could be a data sufficiency, then problem solving, then rotate back and forth. And you could have 5 straight problem solving in a row, followed by a data sufficiency, going back to problem solving. You only see 1 question on your screen at a time, and you cannot preview other questions to come. You can't go backwards and go and change a response from before. So that's the adaptive nature of the test. You really can't see what's coming up, and you really don't know what's coming up until you've answered the question you're currently working on. So everyone that takes this test is going to start off at a 500 level GMAT question, and then based on how you answer that question, you'll get a slightly more difficult question, if you get that question answered correctly, or a slightly more easier question if you answer that question incorrectly. So it definitely pays to spend your time up front, answer those upfront questions correctly, such that you are jumping up in the test. Because the higher you jump up, the higher your score will be, versus missing those key questions up front and jumping down too low. So it's important you understand how the test is structured. It's a very different test from any test you've taken before, such as the SAT or the ACT or even the LSAT or GRE. This test is very unique in that it's scored adaptively.
Before you move on,
sure.
Stephanie, I had a question that came in that was related to your problem solving and data sufficiency questions. And you mentioned that the test is adaptive and that individuals would get a different question based on how they answer. Are problem solving questions more difficult than data sufficiency or vice versa? So in order, if I answer something correctly, will I be more likely to see a data sufficiency or a problem solving? And can I use that to determine whether I answer the last question correctly or not?
Absolutely not. So
okay, good.
There are levels of questions for the two different question types. You can have a 500 level question that's a DS question type, or a 500 level question that's a PS question type. So whether you're seeing more of one type than another absolutely does not indicate how you answer the previous question. So in the testing environment, you do not want to think about, oh, this question is easier than the last question, or oh, I got a DS where last question was a PS. Really, you just want to answer them the best you can and try to get them correctly. And once you're on to the next question, there really is no time to think about how you're doing in the midst of your 75 minutes for the section. So you have to just do the best you can do and make sure that before you go and sit for the actual GMAT that you're as prepared as you possibly can be, so that you are confident in your ability before you go and walk into the GMAT.
Great, thank you.
Okay, now the next slide shows you a breakdown of all the different concepts that are tested on the quant section of the GMAT. So you see there's arithmetic concepts. Again, this is the kind of information you probably learned in 7th, 8th grade, middle school years, things such as number lines, integers, rounding, prime numbers, percents, order of operations, etc. You'll see the list here. All these are things that if you do not remember, you have to spend some time brushing up on these concepts before you can, jump into your GMAT questions. The algebra concepts, exponents are huge on the GMAT. GMAT loves exponent rules, factoring and foiling, absolute value, standard deviation, etc. These are concepts that were taught in your, again, 9th, 10th grade algebra class in high school. And then lastly, geometry. So lines and angles, perpendicular lines, parallel lines, all your different polygons, including your triangles, your quadrilaterals, volume, circles, etc. You'll have to know all those different things as well for the geometry part of the questions on the test. So you certainly want to make sure that these things are current in your head. If I ask, or if you see a question that deals with the area of a circle, for example, you should automatically know what that equation is, such that you're not spending too much time trying to dig up an equation from years and years and years ago. So brushing up on the key equations and rules and formulas are things that will certainly help you out on this test. And as I said earlier, there is no trigonometry, there is no calculus, there is no advanced algebra topics such as imaginary numbers or exponential functions or logarithmic functions. Everything you need for the quant section is listed here on the slide for you. So make sure that you go through the slide and tease out what you do remember and what are some things you don't remember, so you can spend some time reviewing and brushing up on those concepts. Okay, if we move on to the next slide, here are some of the key strategies that are tested on the GMAT, and these are strategies that we're going to talk about today. Some of them we won't have time for, but we're going to talk certainly about the first one, which is the most popular, my favorite, most popular strategy, which is diagramming. And that is such a powerful tool that you can use for the GMAT, and it really helps turn a seemingly complicated GMAT problem into something that's really simple and easy to understand. If you can simply draw a diagram or a table or a picture or a chart or something to visualize the problem, it can help reduce the difficulty of the problem to something that's easier, simpler, and it's more recognizable what to do with the question once you do that. So we're going to do that a lot throughout our time together on the chat. The pick a number strategy is something that you can use for the problem-solving questions only. That's a really important strategy as well. It comes up time and time again. There's 3 different types of questions where you can pick a number. The most common is the first type you see listed there, the variables in the question and the choices. So we'll do an example of that. We'll also do an example of what's called the what fraction problem. And then the third type is the how many problem. So those key terms, what fraction or how many, if you see that in a question, that is your key or your hint that you can pick a number and work that problem out using that strategy. The back solve is another strategy for the problem solving questions only, and again, very, very really helps simplify problems where you can use your answer choices, plug them into the question, and solve the questions based on the choices. So this is what we call working backwards, starting with the choices and plugging them into the question and seeing which one works out. And again, we'll do an example of that as well. Other strategies you can see on this GMAT are pattern recognition. POE is very important. Process elimination is very important, especially when you get to those DS question types. We'll talk about the ADBCE process elimination strategy for the question type. Stop when we have enough information. That's a DS strategy only. Extremes come up time and time again on the GMAT. We'll do an example of a problem that asks you to think about extreme values. Built-in constraints are really important. If you have a question that's asking you about how many stamps you purchase or how many apples you purchase, that built-in constraint there would be you're only looking at positive integers. So any fractional answer, any decimal answer, any negative answer would not make sense if you're trying to quantify the number of stamps or the number of apples purchased or something of that sort. So that's what we call a built-in constraint. Simplify the given and the find. That's a data sufficiency strategy. We'll get to that later on. That's a really important strategy. We'll talk about that in a problem. Don't assume integers only. That's, again, time and time again, I've seen students who see a problem where they say X and Y, is X greater than Y or something of that sort, and they don't consider non-integers. They only consider integers. So if they don't specify that your variables are integers only, then you have to also consider the fact that they could be fractions or could be decimals as well. And the next strategy listed here is the prove it strategy. A lot of times people use their gut feeling to say, oh, this is not sufficient, or oh, this is sufficient. But my response is always prove it to me, because especially when you're looking at those 600, 700 level GMAT questions, proving it with just your gut or kind of answering the question based on your gut only is not going to work most of the time. It's people like, oh, my gut says it's this. Well, my response is always prove it to me. So if you prove it, then you're absolutely confident and sure about your answer versus just using the gut feeling of what you eyeball to be the right answer choice. And then the final strategy listed here is to redraw and label all your diagrams, and we'll get to that as well. But a lot of times you'll see problems, especially with geometry, that give you a diagram or a figure, and because it's a computer-based test, you'll first need to redraw that diagram on your paper, and then you want to label, and labeling helps you to see what's going on in the question. So a lot of times people stare at the diagram and then say, I don't know what to do. And my next response is to label what you know. Write out what you know. Start with what you know, and then it becomes more clear of what to do with the question. So we'll do an example of lots of these different strategies. You'll see how to use them in the questions themselves. And again, as Angela said, if you have any questions as we're going through the problems, feel free to send them in so that I can answer them as we go through the questions here today. Okay?
Fantastic. I think we're ready. So we're going to get into our first set of questions. For those of you who are just logging in, you haven't missed a whole lot. We haven't started the questions yet. Stephanie's been talking through some of the strategies that are going to be related to this here. And then we're going to go through the questions one by one. As I mentioned before, you will get a copy of the deck itself and the video probably about 5 to 7 days after this. So focus more on digesting what Stephanie's telling you and teaching you than trying to make sure that you're kind of writing down those notes. I would definitely advise you to take your own problem solving notes alongside her, but focus more on what she's sharing, and because you'll have the actual questions to go along with it afterwards. So with that, we're going to jump into it.
Sure, and first I need the passcode for the
0817.
Okay, perfect.
We're going to go ahead and get started, and like I said, you'll see the work that Stephanie's doing on a screen alongside, and then we'll start with our first question, which you should see on your screen as official problem solving sample question number 1 from the guidebook by GMAT, which Stephanie can hold up for you.
Let me show you the book.
This is her Bible, if you will.
This is the GMAT Bible,
Right.
definitely. This is the book written by the GMAC, the people who actually write the test itself. So this is the book we'll be pulling questions from today. If you already have this book, 2 thumbs up for you. You can follow along in the book. I'll give you the question number we're working on directly from this book. If you don't have this book already, I definitely recommend that you pick it up from your local bookstore or online bookstore. Again, it has the most realistic questions you're going to see out there because it is written by the GMAT. And these are people, like I said earlier, who actually write the official GMAT questions. So this is the book we'll be using. And the first question we'll do is problem solving 116.
Yep. So I'll read it out loud for the group. If P is the product of the integers from 1 to 30 inclusive, what is the greatest integer K for which 3K is a factor of P? And you see the 5 suggestions or the 5 selections that are there. And the concepts look like definitions of product, integer, inclusive, and factor, exponents, factors, and multiples. And it sounds like we're going to use that strategy you talked about in diagramming it.
Yes.
And this is a mid 500 level?
Yes.
Okay, fantastic.
So this could be one of the first questions you see on your GMAT. This is a mid 500, so maybe a little bit slightly more challenging than a 500 level itself. But this could be one of the first things you see, one of the first 2 or 3 questions you see on the GMAT. So let's see how we would tackle this question. So as Angela said, a lot of the key terms in this question come up, words like integers and products, and we see this exponent K hanging above the 3. So let's understand the key terms first. If P is the product of the integers from 1 to 30 inclusive, then we know that P is going to equal 1 times 2 times 3 times 4 times 5, all the way till we get to the number 30, okay? So the P is the product, which means to multiply all the numbers from 1 to 30 inclusive, which means including the 1, including the 30. So as you see here, there is, I should have said this earlier, there is no calculator on the quantitative part of the GMAT, which means that we could either multiply all these numbers out by hand, which would take us certainly more than an average of 2 minutes per question, or we can think about another way to approach this problem that doesn't allow us to actually calculate this huge product. So let's keep reading. It says that what's the greatest integer K for which 3 to the K is a factor of P. So we're trying to find the greatest integer K for which 3 to the K is a factor of P. So the greatest, an integer we know is a whole number, positive or negative, a whole number. So no decimals, no fractions. Okay, so that's what we know that K is. It's some whole number. So just to kind of refresh you on exponents, if K was equal to, let's say, 1, then 3 to the K would be 3 to the 1, which is just 3, right? If K is equal to 4, then 3 to the 4th would be 3 times 3 times 3 times 3. So essentially the value of K tells us how many 3's we have. Okay, so essentially we can rephrase the question to be, how many 3's do we have that are that's a factor? In other words, factor is divisor of P. So when we look at this product from 1 to 30, what we can really do is tease out all of the numbers within 1 to 30 that are factors, or rather multiples of 3. So from 1 to 30, what are the multiples of 3 in the product 1 to 30? So we have 3, 6, 9, 12, 15, 18, 21, 24, 27, and finally 30. So these are the only factors in that product that are multiples of 3. These are the only numbers that have 3 within them. And if we're trying to figure out how many 3's we have, we're not concerned with the other numbers from 1 to 30. We're not concerned about the 2 or the 4 or the 8 or the 11 or the 13. Only the numbers that are multiples of 3. So now we can count the 3's. We have a 3 here, and then 6 factors in 2 times 3, so there's another 3 there. And then 9 is 3 times 3, so there's 2 more 3's there. Then we have 3 times 4, 3 times 5. We have 3 times 6, but we know that 6 is 2 times 3, so there's 2 3's in 18. 21 has 7 times 3, so 1 3. 24 has 3 times 8, so another 3 there. 29 is 3 times 9, and then 9 we know is 3 times 3, so there's 3 3's in 27. And then finally we have 3 times 10, so there's another 3 there. So if we counted the number of 3's, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, which means our value for K is equal to 14. There are 14 3's that can be factored into our product P. Okay, so the correct solution here would be 14, answer choice C. All right, so as you can see, what I did was I diagrammed it. I took the words in the question and I drew a diagram, a representation of the question, such that it helped me to figure out what it is that I was looking for. Oftentimes, doing the diagram, writing out what it is that you know, and what you're trying to find, and using a diagram to help you solve the question makes the question a little bit simpler to look at. So writing it out this way, when I listed out my numbers and I listed out the multiples of 3 and then I factored those numbers, is a visual representation of the problems asking me to do.
Great.
Okay.
I think we're ready to move on. So you should see on your screen now problem solving sample question number 2. And that was a problem solving problem we heard before, so we're going to do another one in that same space. PS 151. At a loading dock, each worker on the night crew loaded 3/4 as many boxes as each worked on the day crew. If the night crew has 4/5 as many workers as the day crew, what fraction of all the boxes loaded by the 2 crews did the day crew load? And your options there are listed A through E. And the concepts we're testing here seem like we're translating words into operations and fractions. And then this is the diagram and pick a number. So Stephanie had talked before about the idea that this is where you can pick a number to use to test out your theory so you can come up with a solution. This is a slightly higher question. Looks like it's a high 500s, low 600 problem.
Yes, exactly. So here's one that, again, very wordy question. We have 2 different crews in this problem. So when we diagram this, we're going to diagram with our day crew and our night crew. And then the question reads that we have information about the number of boxes that the crews are loading. So we know that the number of boxes loaded, and this is, it's a each worker loaded. So we have to make sure we recognize that it's each worker, not the total number of workers. And they tell us that each worker on the night crew loaded 3/4 as many boxes as each worker on the day crew. Okay, so night crew loaded 3/4 as many boxes as each worker on the day crew. So here's where we get to choose a number, pick a number. If we want to pick a number to represent the number of boxes loaded for each worker on the day crew, we want to choose a number that when we multiply it by 3/4, it cancels out our fraction. So choosing a number that's a multiple of our denominator 4 is going to help us to simplify this question and eliminate the need for fractions. So if I choose the number 4 for the number of boxes loaded for each worker on the day crew, when I multiply 3/4 by 4, the 4 is canceled and I'm left with 3 boxes per worker for each worker on the night crew. Okay, you could have chosen any other number. You did not have to choose 4. You could have chosen 8. You could have chosen 16, 20. Any other multiple of 4 would have eliminated your fraction 3/4 when you multiplied. Would eliminate the fraction, so you would have gotten a whole number for both the day crew and the night crew. If you would have chosen a number like 10 that was not a multiple of 4, again, still would have worked in terms of getting to the correct answer, but would have been a little bit more challenging to solve because you have fractions that you're now having to work with. So we want to choose numbers that make our life simple and easy. So choosing a number like 4 makes our numbers nice and small, and it also helps us to eliminate our fractions. If we continue to read, the problem says, if the night crew has 4/5 as many workers as the day crew, so now we're given information about the number of workers, okay, and it tells us that the night crew has 4/5 as many workers. So again, if we choose a number for the day crew, let's say we choose 5, therefore we multiply by 5, we have 4 workers on the night crew. And then finally, we're trying to figure out the fraction of all the boxes loaded that the day crew loaded. So if we figure out the total number of boxes for both crews, so we know that we have 4 boxes per worker for the day crew and 5 workers in total. So we multiply that, we get 20 boxes altogether. And then we have 3 boxes per worker for the night crew and 4 workers in total. So that's a total of 12 boxes loaded by the night crew. So if we add the 20 and the 12, we get a total of 32 boxes loaded between the 2 crews. What we want to figure out is the fraction of the number of total boxes, so total, T-O-T-A-L, total boxes loaded, that the day crew loaded. So this fraction of the total of the day boxes to the total number of boxes. So that means our day boxes, as we see on this screen here, is 20. And our total boxes we found out is 32. If we were to simplify that fraction, dividing both numerator and denominator by 4, we'll get our answer, which is going to be 5/8. Okay, so 5/8 is the number of day crew boxes to the total number of boxes loaded. Now you could have done this problem using variables, and again, that will work out perfectly. You'll have some extra steps in there. You have to get some common denominators and add fractions. However, picking numbers for this problem really does simplify the question. And of course, our diagram helps to visualize what's going on in the question such that we can keep our information organized and solve the problem as quickly and simply as we possibly can.
Fantastic. So as you can see, Stephanie, when she goes to the problem, she'll share the information there and then have that also on the screen so you'll know. You'll have to make sure when you go through these yourself, you don't cheat and go back and look at the answers first. We're going to move to the third problem-solving question now, which is related to Lois. This is problem-solving question number 184. Lois has X dollars more than Jim has, and together they have a total of Y dollars. Which of the following represents the number of dollars that Jim has? You see the 5 answer selections there. We're testing the concept of translating words into operations, and we're going to diagram it and pick a number. Again, 2 very important strategies that Stephanie has been sharing. This is a harder question, mid to high 600, so this is definitely moving into some of those more difficult concepts.
Perfect. So this is another pick a number problem. Unlike the last question, that was a what fraction problem. What fraction of the day crew, of the total number of boxes the day crew load, that was a what fraction keywords there. This is the most common type of pick a number problem where we see variables in the question as well as variables in the answer choices. So if you look at the question, the first thing that I notice when I read this question is I see the 2 variables X and Y in the question. Then at a glance at the answer choices, I see the variables X and Y also in the answer choices. So that is my key signal that I can choose the numbers for this question. So if we write out our 2 people here, Lois and Jim, and it says that Lois has X dollars more than Jim. So let's just choose 2 numbers for Lois and Jim. We know that Lois has more. So we can say Lois has $8 and we can say Jim has $6. Lois has X dollars more, so therefore our X value will be the difference between those 2 numbers. Or Lois has $2 more than Jim, and together they have Y dollars. So together we add up the 2 numbers now, and together they have $14. Okay? So the key there was we chose 2 numbers for Lois and Jim. We made sure we met the constraints of the question that said Lois has to have more than Jim, and then we simply subtracted to get the difference, which represented X, and we added to get the sum that represents Y. And we're trying to answer the question, which of the following represents the number of dollars that Jim has? So Jim has $6, so this is our answer based on the numbers that we chose. Our answer is 6. So now what we need to do is plug in our values into the answer choices and see which one gives us an answer of 6. All right, so if we look at choice A, we see that A is Y minus X over 2. Y minus X over 2. We plug in our values for X and Y. We'll have 14 minus 2 over 2. 14 minus 2 is 10. I'm sorry, 14 minus 2 is 12. Over 2 will give us 6. So 6 does match the answer we were looking for. Therefore, choice A is the correct answer. Okay, if you plugged in X to be 2 and Y to be 14 for each of the other 4 answer choices, you'll see that you will not get 6 as your answer. And the choice that gives us 6 is the correct choice.
So ironically, this question being harder was a little bit faster to sort of move through once you'd kind of gone through some of the concepts. So I think that what you're noticing that as Stephanie is going to get you more comfortable with diagramming and with picking numbers to make your choices, there'll be some economies of scale you'll get as you move through the problems. That'll make them easier for you to digest. Exactly. And that'll be helpful with the small number of minutes you sort of have to go through on the test.
It definitely takes some practice to get comfortable using the strategies. Mm-hmm. I mean, any habit is going to be hard to form, and so with a lot of practice and effort, working through the problems in the official guidebook, you will get more comfortable, mm-hmm. Not only choosing numbers, but also recognizing when you can and when you cannot pick numbers.
Yeah. Perfect. So we're going to be on question 4 now, problem solving. This is problem question number 186. Of 30 applicants for a job, 14 had at least 4 years experience. 18 had degrees, and 3 had less than 4 years experience and did not have a degree. I think I know what I'm supposed to do here. I have to work with Stephanie to remember how to do this myself. How many of the applicants had at least 4 years experience and a degree? And you'll see the 5 options there. We're testing the concept of overlapping sets, and so you can start seeing those circles, in your head. And the strategy is going to be to diagram that. And again, this is a mid to high 600 problem. So, Stephanie?
Perfect. So anytime we have information that overlaps, in this case we have applicants that have a certain number of years of experience, and we have applicants with a degree, and then we have those that have both of those 2 things, and we have some applicants that have neither of those things. So we want to represent that with what's called a Venn diagram. which is two circles that overlap one another. Okay, and our first circle is going to be the applicants who have at least 4 years or more of experience, and the second circle are people that have the degree or a degree. And then finally, if you're in that overlapping of the two circles, these are people who have both a degree as well as the 4 or more years of experience. And if you're not including those two circles, you're outside the circles and you have neither the experience nor do you have a degree. So there's really 4 different places you can be. You can be inside of the experience circle, you can be inside the degree circle, you can be overlapping, so which means you have both of those things, and you can be outside in the neither space. Okay, and then our total number of applicants we're given here is 30. So we know that all of these things have to add up to give us a total of 30. Okay, so the problem says we have 14 that have at least 4 years experience. Okay, so we put the 14 here. That includes the entire circle of those who have the experience. We're told that 18 have degrees, so the 18 goes there. We're told that 3 had less than 4 years experience and had no degree, which means they're outside the circle, so put the 3 here. And we're trying to figure out how many applicants had both, had experience as well as have the degree. So what is X in this case? Okay, so we have our visual representation. We've diagrammed the problem. We have our visual representation of what's going on in the question. So now it's simply time to figure out what our missing value is. What is the value of X? In this case, the number of people who have both the experience and the degree. So we take our 14, we add our 18, and we remember that 14 to 18 include the people that overlap. They include these people in the middle that have both, which means we need to subtract them out one time because we don't want to count those people twice. Then we include the people who have neither, and that should equal our total number of applicants, in this case 30. Okay, so then from this point it's just algebraic equation with one variable. We add up 14 and 18 and add 3. We get 35. We have 35 minus X gives us 30. So we can solve this, and then we'll figure out that X is going to equal 5. All right, so therefore 5 people will have both the experience as well as the degree. So again, any problem you encounter that has overlapping information, other problems I've seen deal with, some people speak French, some people speak Spanish, some people speak both, some speak neither. So you have to figure out, what's missing there, or you'll have people who are part of one club and people who are part of a different club, people who are part of, both clubs and neither.
Right.
So figuring that out. So you'll see these types of wording on the GMAT in many different instances, and representing the question with a Venn diagram is a really important tool to use to diagram it so that you can visualize the problem and really be able to solve the question as quickly as you can.
Great. We're going to get ready to move to the next question, but before we do, there's a question that came in about the last problem for 184 that had to do with choosing numbers. And so the question was, do you ever have to re-pick numbers? So is there ever a time, I guess, where you would use one and there could be maybe multiple answers in the solution set that fit the number that you have? And if so, how do you know when to re-pick the numbers?
Sure. Yes, that's a great question. And yes, there are times where you want to, where you will have to choose more than one number. For this kind of question, though, making sure that you choose a number that has nothing to do with the answer choices is really important. So if you go back to that question with Jim and Lois, you'll see the choices have divide by 2, they're minus 2, etc. So the really only number you want to stay away from is the number 2. So that way you don't have to worry about is there more than one choice is going to work. So for that question, I would not pick the number 2. We chose number 8 and 6. So we're safe there. I also generally stay away from the number 0 and the number 1. Okay, we know those two numbers have special properties, especially when it comes to division. You can never divide by a 0. And when it comes to multiplication, multiplying by 1 just gives you the same thing you started with. So choosing 0 and 1 is always tricky because you'll have some choices that are undefined if you have a division by 0. You have some choices that are the same if you have a multiplication by 1. So when you're choosing numbers, you want to choose small numbers. You want to choose numbers that make your life easy. You also want to choose numbers that you don't want to. You want to stay away from the 0 and the 1. So choosing 2, 3, 4, 5. Those are all perfect numbers to choose to start with. And then some questions will say x is greater than 8. So in that case, you want to choose the smallest possible number, which in that case will be 9. So of course you have to meet the constraints given to you in the question. But if it says x is greater than 8, starting with the number 9 will be a good choice for for the number you want to choose. If it says, x is a positive integer, starting with the number 2 or 3, because we all know that 0 is not positive. And we also want to stay away from 0 and 1 in general when we're choosing numbers. So just making sure that you're meeting the constraints in the question, you're staying away from 0 and 1, and you're looking at your answer choices to determine, are there any numbers in the choices that you want to stay away from? If you do those things, then you won't have to worry so much about having more than one choice that works.
Great. So we're going to move on to question number 5. So this is still in the problem solving. We're getting ready to move to data sufficiency shortly. Xavier, Yvonne, and Zelda each try independently to solve a problem. If their individual probabilities for success are 1/4, 1/2, and 5/8, respectively, what is the probability that Xavier and Yvonne, but not Zelda, will solve the problem? You see your 5 answer choices there. The concept we're testing here is probabilities. That's a newer concept, but we're still using the strategy familiar, which is diagramming. This is a high 600 to low 700 level question, and I will turn it over to Stephanie.
Okay, great. And as Angela was reading the question, I was already going ahead and stepping my diagram, okay, as hopefully you're doing yourself as well. So by now we know that we need to have a diagram that represents the question so that we can easily see what's going on. We have 3 different people here, Xavier, Yvonne, and Zelda, represent that with X, Y, and Z. And then we're also given their probabilities for success. Okay, so success for Xavier is a 1/4 probability. For Yvonne is a 1/2 probability, and for Zelda is a 5/8 probability. Okay, so we write those down so that we can see, again, what we're given. The word respectively that appears in this question is in that particular order. So they listed those 3 names in a certain order. They listed the probabilities in the order to match the order of the names that were listed. So we want to keep them in order. And then we're asked to figure out what is the probability or the chance that Xavier and Yvonne will succeed, but not Zelda. Okay, so the not is a really important concept to understand here. If you're trying to figure out the chance of something not happening, the key to do that is to subtract it from the total probability, which is always 100% or the number 1. So the chance of Xavier not succeeding will be 1 minus 1/4, which is just 3/4. For Yvonne not succeeding will be 1 minus 1/2, which is equal to 1/2. And for Zelda not succeeding will be 1 minus 5/8, which is 3/8. Okay? Now the question wants us to have success for Xavier, success for Yvonne, but not success for Zelda. So when we figure out our response to this, we need to make sure we're using the correct probabilities. In this case, the 1/4 for Xavier, the 1/2 for Yvonne, and the 3/8 for Zelda, not the 5/8 for Zelda. When we want all 3 things to happen, we want Xavier, yes. We want Yvonne, yes. We want Zelda, no. We want all 3 things. We multiply those fractions. 1/4 by 1/2 by 3/8 gives us 3/64, which is our correct answer response, E in this problem.
Correct.
Okay, so for probability, again, remember and means to multiply. If you see or, if it said Yvonne or Xavier, you would add in that case. Okay, or means to add and means to multiply. In this case, we want all 3 things. We want an and, so we multiply those 3 fractions to get our probability of all 3 things happening.
Fantastic. So I got one more question on 184 before we leave, because I think that the choosing the different numbers came up more than once. And it sounds like there's some questions about, for 184, and I'm going to bring that question back up for you guys so you can see it there on your screen again, that they're asking about Lois and X dollars more than Jim. And there's a question as to whether or not answer A, which is Y minus X divided by 2, or answer C, which is Y minus 2 divided by X, would both be correct when worked out, both equations equal 6.
So if that's the case, then thank you for pointing that out. Let's try it. Choice C says Y minus 2 divided by X. So Y we said was Y was 14, right? So 14 minus 2 divided by X we said is 2. So that will be also equal to 6. So somebody pointed that out, which is excellent. So what this means is that we got 2 choices that work. We got A and C, which means the numbers we chose were not good. So perhaps our X value equaling 2 when we have 2 in our answer choices was not a good idea. Okay, I said stay away from numbers in the answer choices because we see 2 in our answer choices. Having a difference of 2 was probably not the best idea. So let's redo the problem.
Okay.
We're going to redo the problem choosing a different difference this time. We're going to have a difference of maybe 3 or 4 or 5 or 6 or anything else but 2. Okay? So I'm going to go to a new screen here. And we have, again, Lois, and we have Jim. Well, let's pick for Lois, he has more, so let's pick 10 for him, and let's say Jim has 5. So in this case, our X is going to be 5, not 2, so that's good, and our Y is going to be 15, okay? So now we go back to those 2 choices, A and C. Only one of them should work this time. A says Y minus X divided by 2, so that's going to be 15 minus 5 divided by 2, so that's 10 divided by 2, which is 5, which matches our answer for Jim. So A still works. Let's go to choice C now. C says Y minus 2 divided by X. Now we have 15 minus 2 divided by 5, which is 13 divided by 5, which is not equal to 5. So that one doesn't work anymore. Okay, so the rule there, the kind of lesson learned there is the difference of 2 was not a good idea when we saw 2 in our answer choices. So we should have chose something different for our numbers that we picked. Because if you choose numbers that are not your choices, you don't run into that problem happening where you have more than one choice that works. So thank you for the person who caught that. And in general, once you get to your answer that works, you should be confident in that answer as long as you have stayed away from numbers in the choices.
Fantastic.
Okay, so that's that. So again,
Great.
choosing numbers, different numbers, led us to only one answer choice versus having the 2 that we had before.
Fantastic. So thank you again out there. I'm going to go ahead and move us to the data sufficiency section to make sure we're staying on timing, since we went over that question there twice. So we'll have a little bit more time to go out through there. So we're going to start with data sufficiency, and Stephanie's going to talk a little bit about data sufficiency answer choices, because there's a lot of uniqueness in the answers that are there that will help a person or hinder a person to be able to answer the question. So
perfect. So on this slide, you'll see the 5 different answer choices, A, B, C, D, E, and it's very important to understand what they mean, such that when you get to the real test, you don't have to keep rereading them to understand their meaning. So choice A means that statement 1 by itself is sufficient, but not statement 2. Choice B means that statement 2 by itself is sufficient, but not statement 1. Choice C means you need both statements together that by themselves are both not sufficient, but if you bring them together, you have a sufficient response. Choice D means that them independently are sufficient, again, by themselves. So A and B or statements 1 and 2 together are sufficient alone. And then E means you need more information. You can't figure out the response with the statements that are given to you. So knowing them and having their meanings in your head is really, really important. If you go to the next screen, you'll see a diagram that helps you to use POE to eliminate answer choices here. So if we have 2 columns, one column for A and D, the second column for B, C, and E, and we go to our first statement, which says we answer the question, is that sufficient or not? If we answer the question yes, we're on the left-hand side of that diagram. If we answer the question no, we're on the right-hand side of the diagram. So if we answer the question yes, it is sufficient, then we eliminate B, C, and E right away. Okay, if you say the statement 1 is sufficient, your answer choices cannot be B, C, or E. You're only looking at 2 choices at that point, A or D. If you then go on to the second statement and you say the second statement is also sufficient, then you choose D over A. But if the second statement is not sufficient, then you choose A over D. Okay, and that is the end of that with the first choice being sufficient. 2 responses, choose from A or D. You look at the second statement. If that's also sufficient, you choose D. If not, you choose A. Now, going to the right-hand side, if the first statement is not sufficient, you eliminate that first column, A and D, and now you have 3 choices left, B, C, or E. Then you go to the second statement. If that statement is sufficient, then you choose B and you're done. But if that statement is not sufficient, you eliminate B, and at that point is the only point where you consider both statements together. So now we look at both statements 1 and 2 together. If together you're sufficient, you choose C. If together you're not sufficient, you choose E. Okay? So really, really, really key that you understand how this diagram works, how to eliminate answer choices, setting up in columns so that you eliminate one column or the other column. If for some reason you get stuck on statement 1 and you rather go to statement 2 first, that's okay. Just simply reverse the A and the B, so your column would be BD, ACE versus AD, BCE. Okay, all you do is flip the A and the B. That way you're focused on statement 2 first. And then you can go back to statement 1 after you've discovered statement 2. Okay, so I think we're ready for the first question.
So as you're looking through this, and I wish that there was some easy way for me to leave up on the screen the chart, but I won't be able to. You'll have the slides afterwards. I'll refer back to that as she's going through and changing and scratching things off. But the two brackets that she described, you can see up on the screen now in terms of sufficiency. And that will be something that as soon as you can write that out, it will really help you to kind of get through and move through the questions. So we're going to get to the first question, and once the question's read, I'm going to put back up that slide so you can see those two paths. I think that's probably more important than the question, which Stephanie will be talking to. So the question here for data sufficiency number 72, if m is an integer, is m odd? Option 1 says m divided by 2 is not an even integer. And option 2 says m minus 3 is an even integer. So we're testing integers, even, and odd rules, and the strategy is to not assume integers only. And this is an entry level, it's a 500 level question, right? So the kind of level you'd start with, if you will.
Exactly.
Here. And so Stephanie's going to work through the problem, and again, I'm going to put that slide up again that you saw before, when necessary. So you'll go to, back and forth between those two. So Stephanie?
Okay, great. So again, this could be the very first question you see on your GMAT, okay? So 500 level question. The next question you see determines if you can get this question answered correctly. And you'll notice here I've set up my screen such that I have G and F. G stands for given, F stands for find. And it's very important to write out what you're given and what you're trying to find before you even get to the statements, because you have to understand those two pieces to understand, what the statements mean. I also have written here my A, D, B, C, E column such that I can eliminate what I need to eliminate to get to the correct choice. So in this problem, they tell us that m is an integer. So my given information is m is an integer. And they ask us to find out if m is m odd. Okay, so in this case, this is a yes or no question. Yes, it is odd, or no, it's not odd. All right, so we'll get to the even odd rules later on, but understand the given and the find is a really key step to any DS question type. In this case, it's pretty simple and straightforward, so there's nothing really to ponder over, just to know what you're dealing with. So we'll look at the first statement that says m over 2 is not an even integer. Okay, so the strategy here is do not assume integers only, which means that if it's not even, then what is it? M over 2 could be odd, but m over 2 could be a non-integer. It does not have to be integer at all. Okay, it could be an odd integer, or it could be a non-integer, which means a decimal or a fraction. Okay, so keep that in mind whenever you see something that's not an integer or not an even integer. The opposite of that is not simply just an odd integer. The opposite of that is an odd and or a non-integer, such as a decimal or a fraction. So in this case, we know that we have to equal something that's an odd or something that's not an integer. So if we choose, let's say, m to be 10, 10 divided by 2 is 5. 5 is an odd integer, so that does meet the criteria outlined in statement 1. And therefore, if we go back to the question, is m odd, we can safely say, no, m is not odd. Okay? So with that number we chose, m to be 10, no, m is not odd. But then the question is m not odd 100% of the time, or is there a case you can think of where m could be even? So if we go back and think about another value for m, try an even value for this time. So let's say m is, let's say 12. 12 divided by 2 gives us 6, but that doesn't work because in that case 6 is even, and we want something that's not even. So we can erase that. Now let's try 7. Okay, I'm keeping my numbers nice and small. If we say m is 7, then we have 7 divided by 2, which is not an integer. Right? It's not even, so therefore it does fit our criteria. In this case, we have m to be 7. Is m odd? Now we have a yes. M is odd. So because we have a no and we have a yes, we've safely shown, we've proved that statement 1 is not sufficient. We have to eliminate A and D because we cannot say whether m is even or odd with that statement by itself. Okay, A and D are the two answer choices that we can eliminate.
Okay, so as you're looking at that screen that I have up right now, again, she's crossed out both A and D, which is going to leave you with B, C, and E, which is a much easier subset to try to choose from if you're in a time crunch.
Exactly. So we're on the right-hand side of that diagram. We've answered statement 1, no. So now we're looking at statement 2 to figure out if we are sufficient. Otherwise, we have to look at them both together. So statement 2, I'm going to go to another page here. Statement 2 says that m minus 3 is even. Okay, and this is what we need to know our even odd addition subtraction rules. We know that an even plus or minus an even is even. An even plus or minus an odd is odd, and an odd plus or minus an odd is even. So these are the rules that you need to know when it comes to addition subtraction with even odd integers. Okay, so if we look at our statement 2, we're equaling something that is even, which means we can eliminate this second rule here because that's equaling an odd. So we're looking at either the first rule, even plus even is even, or odd plus odd is even. But this 3 tells us that 3 is being an odd number, tells us that the first rule is also out because we're looking at one even, one odd equaling, subtracting an odd from something to get it even. Which means it's the third case here. In order to get it even with an odd, you have to subtract 2 odds to equal an even. Therefore, m must be an odd. So because it must be an odd, then we are sufficient. So we go back to the previous screen. Sufficient means we choose B and we eliminate the other 2 choices. Okay, if statement 2 is sufficient, you choose B and you're done. Statement 2 was sufficient because we could determine that m is an odd integer, and that means the statement is enough to say yes to that question.
Great. So I think there's a couple things to kind of walk through for this. Having that graph in your head, or even if you chart it out as soon as you sit down, to start your test, you can't bring it in there with you. You have to.
No, you can't.
You can't bring anything with you, so you'll have to chart that out as soon as you sit down. But understanding that left and right, that A, D, and B, C, E, will let you kind of mark through it faster to figure out your answer. And the test is trying to determine your ability to understand sufficiency, not to solve the problem necessarily.
Exactly.
So once you have reached the point where it is sufficient, you don't need to do any more work. You're wasting more time at that point.
Right.
So making sure you have this there will kind of save you some time. She didn't need to go through the additional answers. She can stop at that point.
Exactly. I knew it was B for that point. There's no point in debating over C or E. Okay.
Right. So in general, we're going to go to a second question, but in general, as you're looking through this, oops, I think I jumped ahead. Yep, data sufficiency sample solution number 3. So we're going to look here in terms of the question for number 3, which is DS 120.
Okay.
Okay? A certain bookcase has 2 shelves of books. On the upper shelf, the book with the greatest number of pages has 400 pages. On the lower shelf, the book with the least number of pages has 475 pages. What is the median number of pages for all of the books on the 2 shelves? And the statement 1 is there are 25 books on the upper shelf. Statement 2 is there are 24 books on the lower shelf. We're testing the median concept here. We're going to diagram it again, which Stephanie is doing as we speak. And this is a low to mid 600.
Perfect. So again, this problem is screaming to diagram me, diagram me, diagram me. So if we have 2 shelves, we have an upper shelf and a lower shelf, we can diagram what those 2 shelves will look like. So I just represent the shelf with a line here. And it says that the upper shelf that has the book with the greatest number of pages. So we put these books in order because we know that median's asking us for the number in the one in the middle. So we order them from the least to the greatest on the upper shelf. We know the one on the very far right is going to have 400 pages. So we put a 400 there for that book. And then we have so many books to the left of that one. Our lower shelf, the book with the least number of pages is 475. So we diagram a 475 page book on the left. And then we know we have books to the right of that one. Okay, we don't know how many, but we know we have so many books on the left of the 400 page book on the upper shelf. We have so many books on the right of the 475 page book on the lower shelf. And that the 400 is the greatest, which means is the one on the very end, and the 475 is the least, which means the one on the very end as well on the lower shelf. And we want to know what's the median. So our find is the median of all median number of pages for all the books on the 2 shelves. Of all books on the 2 shelves, which means what I need to do now is sort of put these 2 shelves together onto one shelf. And if I do that, make it to one shelf, I know that the book with the 400 and the book with the 475 are going to be right next to each other. Okay, because I have my greatest from the upper shelf and my least from the lower shelf, and those two books are going to be side by side when I put all the books on one shelf. But what I don't know is what goes to the left and what goes to the right in terms of how many books I have in total. But I know those two books are side by side. So that is my given information. That is my diagram that helps me visualize what I need. And what I need to solve this question is, how many books do I have in total? If I can figure that out, then I can tell you, then I can figure out if I can tell you the number of pages for the median. So if we go to statement A, or statement 1 rather, statement 1 tells us we have 25 books total on the upper shelf. So 25 books on the upper shelf means that we have 24 books to the left of the book with 400 pages. Okay? So without knowing information about the lower shelf, that's not going to help us get to our answer. We can't figure out the median because we still don't know where the middle is. We only have information about one shelf, not the other shelf. So therefore we can eliminate A and D. Those two choices are out. So now we're looking at statement 2. We have to ignore statement 1 for a second. So I'm going to erase statement 1. Okay, that we don't know yet. We're looking at statement 2 by itself. And that tells us we have 24 books on the lower shelf, which means we have 23 to the right of the book with 475 pages. But again, now we don't have any information about the upper shelf. Okay, so we cannot figure out the median without having our total number of books. So we can eliminate choice B as well. So at this point is the only point we consider both answer choices together, both statements 1 and 2 together, to see if together we have enough information. So together we know we have 24 books on the left of the 400-page book. We have 23 books on the right of the 475-page book, which means we know that this book here is the one right in the middle. We have 24 to the left of it, and we have 24 to the right of it, which means it's the book dead in the middle of all the books, which means we can answer our question with both statements. The median number of pages for all the books on the two shelves is 400. So we choose our answer choice C as our final answer, and we eliminate choice E.
So that was a different kind of process of going through it because you had to get to the third level of whether it could be combined or not. But again, you save yourself time when you're crossing through those things to determine that if this one by itself is not sufficient, now we can move and figure out if together they will be.
Perfect. And if you got stuck on the statements together, it's say you eliminated A and D, you eliminated B, and then between C and E you weren't quite sure. Well, at least at this point you're guessing between two choices versus guessing as 5 choices. So it really does help you if you have to make a guess, to guess between fewer choices for the DS questions.
To make as most educated a guess as possible. I skipped over question number 2 and got us to question number 3, so I'm going to go back to that one and make sure we're not missing that. So if you should see on your screen data sufficiency sample question number 2, which is DS 98. And the question is RST equal to 1? Statement 1 says that RS equals 1, and statement 2 says ST equals 1. We're testing here the idea of integers and fractions, and a strategy, again, we mentioned, do not assume integers only. This is a level mid-500, so this would be a little bit easier than the one we just did, question 3, and a little harder than the first one that we went through.
Perfect. So here, our given information doesn't exist. There is nothing given to us, right? We're just asked the question, is RST equal to 1? So, yes or no question. We cannot assume, as the strategy says, we cannot assume that R, S, and T are integers. And that is the biggest mistake people make for this particular type of question, is that they automatically assume that R, S, and T are whole numbers. Mm-hmm. Nothing tells us that they are, so we must also consider the fact that they could be fractions, they could be decimals. So that's really, really, really key that you keep those things in mind as you go through the two statements 1 and statement 2. So statement 1 tells you that R times S is equal to 1. So, of course, to equal 1, we could have many different options. We can have R and S to be both equal to 1. We can have them both be equal to -1. We can have them equal to, fractions, and one being a fraction, one being an integer to cancel out and give us 1. There's way too many options, but the key thing here is that there's nothing given to us about T. We have R and S, but there's nothing here about T. So T could be anything, which means that we cannot answer our questions. RST equal to 1, we do not know. Nothing about T. So we eliminate A and D pretty quickly because we're lacking information about one of our variables. If we look at our second statement that says S times T equals 1, here we have nothing about R. Nothing's given to us about R. So once again, we can quickly eliminate choice B, because with nothing about R could be anything, anything you can imagine, and so we can't tell you if the product is going to equal 1 or not. So at this point, we consider 1 and 2 together and see if together we have enough information. So together, what most people assume is that each of these variables individually is 1, which is how you get RST equal to 1. RST equal to 1 and ST equal to 1. But what you have to remember is that R could be something like 1/4 and S could be something like 4. If you multiply 1/4 by 4, you also equal 1. Okay, so again, thinking about non-integers, because they didn't specify that these are integers, is really, really key to helping us see that it could be the case they were all equal to 1, but it does not have to be the case they're all equal to 1. They could be fractions and decimals in here. So if that's the case, here's an example of this being not all equal to 1. R is 1/4, S is 4, and T would be 1/4 as well, which means that the product of 1/4 by 4 by 1/4 is a fourth. Is a fourth. So no, this is not going to be equal to 1. So therefore C doesn't work either. We have to choose choice E. So we could have them all equal to 1, R equals 1 equals S equals T, or we could have a situation where R is a fourth, S is 4, and T is a fourth, or any other fraction combination that still fit the statements that were given to us. So remember, if it doesn't tell you that your variables are integers, must think outside the box and think about non-integers as well.
All right, and that's important advice to get in terms of when you're going through it. Those are key words you're looking for, is whether it says clearly that it's an integer, because your first thought is going to be that two numbers together is going to, if it's 1, it's going to be whole numbers.
Right, S times T is 1. Oh, therefore they must individually be 1 or -1.
Correct.
Right? But it doesn't have to be 1 or -1. Could be a fraction in there as well.
Absolutely. So we're on sample question number 4 now, so we're getting a little bit more difficult. This is DS question number 154. A report consisting of 2,600 words is divided into 23 paragraphs. A 2-paragraph preface is then added to the report. Is the average, meaning arithmetic mean, number of words per paragraph for all 25 paragraphs less than 120? Your two statements are as follows. Each paragraph of the preface has more than 100 words, and each paragraph of the preface has fewer than 150 words. The concepts we're testing here are averages, and we're manipulating inequalities. And so the strategy here is to simplify the given and the find. So Stephanie talked about those two things, the G and the F that you're going to put down first. This is a high 600 problem. So let's go ahead and let Stephanie work through this one.
Perfect. So I brought up this strategy because so many people want to jump to statement 1 so quickly. They just can't wait to get to statement 1, and they don't spend the time where it really matters, which is on the given and the find. Okay, so before you go to the statements, make sure you spend a few minutes reading the given, reading the find, simplifying as much as you possibly can before you go on to statements 1 and statements 2. Okay, so here they tell us that you have a report that consists of 2,600 words. So again, you see my diagram. And that's divided to 23 paragraphs. Okay, so I am just writing the information in the question into my diagram. Then it says we're adding a 2-paragraph preface to this report. So we're adding 2 more paragraphs. And then we don't know how many words are added. So we can just call this X words. Okay, so these 2 paragraphs together have X words. So not individually, but together these 2 paragraphs have X words. So our total number of words after the addition of those 2 paragraphs will be the 2,600 from before plus the X, and our total number of paragraphs now will be the 23 plus the 2, which is 25. And we're asked to figure out is the average number of words per paragraph. So number of words will be 2,600 plus X per paragraph, which is 25 paragraphs. Is that average less than 120? Okay, so here's our find. Is this average less than 120? And this is a yes or no question. Okay, so we first diagram our question, we wrote out our given, we wrote out our find. But before we go to statement 1, is there any way we can simplify this inequality we're given? Certainly there is. We can simplify by multiplying both sides by 25. Okay, And therefore, we get something more easy to look at. 2600 plus x is it less than, if you multiply, you get 3000. Okay, it's 120 times 25 is 3000. Then subtracting 2600 on both sides, I'm going to go to the next screen. If you subtract 2600, you'll get is x less than 400. So this is now our find. And this find is a lot easier to look at than our previous find written this way.
Right.
So we've simplified as much as we possibly could. We're trying to figure out is x, and x represents the total number of words for the two paragraphs that were added. Is x, that total, less than 400? Okay, so again, our A, D, B, C, E, and now we're ready for statement 1. So we have really studied the given and the find, and now at this point we're ready. So statement 1 tells us that each paragraph in the preface has more than 100 words. So if each has more than 100, we know together they have more than 200 words. So statement 1 tells us that x, which represents the number of words for both paragraphs, is greater than 200. We're trying to figure out is x less than 400. So this statement is not sufficient because it could be less than 400, but it does not have to be less than 400. All it has to be is greater than 200. So that's not going to be sufficient. We eliminate choices A and D. Okay? Statement 2 now tells us that each paragraph of the preface has fewer than 150 words. So each paragraph has fewer than 150, so together they have fewer than 300. All right, so can we answer our question with statement 2? The find says, is x less than 400? Statement 2 says, x is less than 300, which means, yes, it has to be less than 400. If it's less than 300, which means we choose B for our answer, we eliminate the other two choices, and we're done. Okay? Right. And what we were able to see with those two statements pretty quickly, because we simplified our find, was that pretty quickly we determined that one was sufficient, one was insufficient, because we simplified our find. If we had not simplified that find, it would have been more challenging to figure out those statements and if they were enough or not. So I really do challenge you to make sure that you are simplifying as much as you possibly can before going to statements 1 and statements 2.
Absolutely. And I think there's a lot of kind of good information in here and thinking about how to digest the problem before you even start to try to solve it. So that being most key. I'm going to move us ahead a little bit and let's try a slightly harder problem. Stephanie's got some great ones in here. And I'm going to move us to question number 6. And data sufficiency question number 6 is DS 162. And the question reads, is 5K less than 1,000? Statement 1, 5K plus 1 is greater than 3,000. Statement 2, 5K minus 1 is equal to 5K minus 500. We're testing the concepts of exponent rules, equations versus inequalities. The strategy here is to stop when you have enough information, as Stephanie's been saying. When you know the answer, stop. And this is a harder question. This is a low 700, so we're going to give us some time to work through this one and let Stephanie answer any of your questions that you have from here. So, Stephanie?
Okay, great. So this is a pretty straightforward question. We don't have anything given here. It's just a question. Is 5 to the k less than 1,000? And we have to know something about exponents because, again, we have this k value here, this exponent lingering here. And so that is, there are some rules that we need to understand. We'll see that when we get to the statements. But there's nothing to simplify. There's nothing to rewrite or to organize in any way. There's no table we can do with this problem. So we're just ready to jump into statement 1. So statement 1 tells us that 5 to the k plus 1 is greater than 3,000. So using what we know about exponent rules, we know that when we multiply with the same base, we can add our exponents. So statement 1 has done that. It has added exponents because the previous step must have been multiplying by the same base. So if we kind of go backwards, we can break this up and say it must have been 5 to the k times 5 that gave us k plus 1. So we just broke that into two pieces and two exponents instead of one exponent. I can put the 1 there so you can see we simply added k plus 1 to get to the exponent in the previous step. So with it written this way, what we can do is divide both sides by 5 such that the 5's cancel on the left side, and that simplifies to give us 5 to the k is greater than 600. Okay, so our question, our find is asking, is 5 to the k less than 1,000? And we know 5 to the k is greater than 600, which means, yes, it could be less than 1,000, but no, it does not have to be less than 1,000. So therefore, we're insufficient. We have to eliminate choices A and choices A and D. Okay, not enough information. It could be, doesn't have to be. We eliminate those two choices.
So we're going to be on that right side of the options.
So on the right side of the options, exactly, looking at now statement 2. So if we look at statement 2, which says 5 to the k minus 1 equals 5 to the k minus 500. Okay, now it's very important that you know that when you have one equation with one variable, you can solve for that variable. In this case, that's what we have. We have one equation. Okay, here's our one equation. And we have one variable, which is k. Therefore, we can solve. We can find the value for k. And then we have that value for k. We can figure out our answer to our question. So we're done, and we choose B. And that is really, really hard for people to do that because most want to actually solve and get the value for k. But we know that we can get the value for k, so we are done with the question. I love that. You're done when you know you can. You don't have to do it.
Right.
So this strategy of stopping when you have enough information is really, really, really important because you're wasting time at the point where you start to solve for k. Why? You're wasting time. You know you can do it. You have one equation with one variable. You can solve it, which means you can answer the question, which means you're done with the problem. You're ready to move on to the next one.
Absolutely. So I think the main takeaway you'll have from the sessions that Stephanie has done today, the problem solving and the data sufficiency, is that you need to make sure you're answering what they're asking. Not necessarily trying to answer the problem or trying to deliver something additional. If they're asking you only whether you can answer the question with the information and it's sufficient, then you've solved the problem. I'm going to leave us the last 10 minutes to go over Stephanie's study plan to optimize. I think this is really important for you guys to sort of digest and get the idea of how to go through a study plan and put that together so you can optimize your time in advance of the exam. And also because I know Stephanie's got some great options and opportunities for people who are still looking for test prep prior to their testing.
Perfect. So there are some other problems in the slide deck you'll get later on that you can review and look over. And it's really key that you understand those strategies we listed before, what they are, how to use them, and you practice them using the official GMAT study guidebook, okay? So we did a number of problems together today. Hopefully you were able to follow. If you have questions after this presentation is over, you'll have my contact information in the presentation. Certainly shoot me an email or a phone call to ask me specifically about the questions. I'm happy to answer your questions beyond today's call.
We had a question actually earlier,
Sure.
about whether there was a Kaplan book you recommend. I know you recommend this GMAT book, and that's probably your primary use, but is there a Kaplan book that you'd recommend instead, or in addition?
Sure. There are so many books out there, Kaplan and other books as well, that it's really kind of up to you, but what I recommend generally is always the official materials. Because these people actually write the test, I don't think there's any better book on the shelf than the book that's written by the test makers. Every other test prep company, what they do is they take the master book and they try to recreate questions written by the test makers. And some people do a good job with that, some people, don't, but you really can't get a better set of questions to practice than the ones inside the official GMAT book. So if you happen to have another study book that you've had before previously, then I say use those books almost like in dictionaries. Use those books as reference guides. If you're struggling with rates or struggling with proportions, you can use those books to quickly read about rates or read about proportions before you go back to the master book, I call it, the Bible for the GMAT. So use those books as supplementary dictionary-ish type of books, just like you will Google something really quickly or you will read something online quickly about a topic. Those books are good reference books, but they're not the kind of book you're going to have to necessarily do cover to cover. If you don't have a second book out there, all you really need is this one book. But if you happen to have another book, use it as a reference guide. If you want another book, use it as a reference guide. But make sure you master this book cover to cover before you go take your official GMAT. Okay.
Perfect.
So again, review those strategies mentioned earlier. Those are really some key critical strategies to tackling these GMAT questions. And definitely create a study plan for yourself. The GMAT is really can really be intimidating, especially if you don't have a plan of action or a plan of attack to make sure you're ready for the test. And it really does sneak up on you. Once you set your GMAT date, you really have to kind of go full force to make sure that when that date comes, you're fully prepared for the GMAT. So what does it mean to be fully prepared for the GMAT? It means that you are committed. Number one, you're committed to studying on a regular basis, and you're committed to taking the time you need to make sure you get the score you need to get. So you should have a certain score in your mind, what we call a target score, that you're aiming for. And then you also want to kind of have a baseline score of where you are before you even start any sort of prep, whether it be self-study, whether it be a test prep course. You want to figure out where are you before any test prep begins, and how far are you from achieving your target score. So what I recommend is that you go to MBA.com. You can download their GMAT prep software onto your PC or your Mac for free, and you can take that practice test on that site. Okay, and if you take that practice test, it will score it for you. You will get a score, and that's a good baseline score that you can see, okay, I'm at a 500, I'm at a 550, I want to get to a 650, I want to get to a 700. I need this many more points total to improve my score. And within that, I need to improve my quant score by this much and my verbal score by that much so that I can achieve the score that you're trying to get to. Okay, so that's step one, is to sit down soon, today, tomorrow, go to that website, MBA.com, download the GMAT prep software, take a practice test, compare that practice test to what your ideal score would be like, and that will help you figure out what sort of next steps in terms of test prep or self-study or books or what have you need to do in order to achieve that target score. And then what you want to do after you take that practice test is create a study plan. And that's really looking at the calendar, trying to figure out when you're going to be ready to take your official test. Go ahead and look and see what test dates are available, because you'll be surprised how quickly some of the test dates fill. And but there's lots of testing centers across the Atlanta area, across wherever you may live. There's plenty of testing centers nearby. So just go ahead and research the closest center to you. Figure out what dates are available, what times of day are available. There's weekend days, there's weekday days, there's morning, there's afternoon, there's evening. So check that out so you can figure out, okay, I'm looking at March time frame, this particular day, and if possible, go ahead and lock that date in. Go ahead and lock it in. That will give you a goal to work towards. And once you have a date in mind or a date already locked in, then comes the time to plan out every single day leading up to that test day. Really, really important that you document and really think about what it's going to take to get from your initial score, your initial baseline score, to your target score in terms of a study regimen for the next month, 2 months, whatever amount of time you give yourself to take the official test. And your goal in that time is to really conquer, again, this official GMAT book as much as you possibly can, as well as taking those online practice tests. You want to take 5, 6, 7 online practice tests on that same website. Take those same practice tests multiple times, because they are adaptive and they will give you different questions every time you take those tests, okay? So feel free to take those 2 practice tests 3, 4, 5 times each until you have gotten enough practice on the computer to figure out what your testing strategy is going to be and how you're going to accomplish reaching that score. Okay? The other things to remember when you create your plan is that you want to plan around certain holidays, birthdays, anniversaries, vacation, work events, etc. that are coming up. So if you know, for example, you have an anniversary coming up this weekend, then don't schedule yourself to do 2-3 hours of GMAT prep on the weekend when you'll be busy with other things. So make sure you plan around certain things in advance such that you don't fall behind your plan. You never want to set a plan that's not realistic for yourself. Okay, so look at what's coming up in your personal life, your work life, your family life, and plan around that when you set your plan and set that plan in action. Do something every single day to prepare, whether it's simply reviewing flashcards of exponent rules or reviewing reviewing all your geometry equations, your equations for circles and triangles and quadrilaterals and etc. Reviewing something every day to kind of keep the ball rolling, keep moving forward, keep that GMAT thinking going throughout the day is so much better than cramming and waiting to do all your studying on just one day, like a weekend day. Like, oh, Saturday I'm going to study for 6 hours. That is not the best strategy. What you want to do rather is break it up and do a little bit every day, and then, save your Saturday for maybe a practice test or something like that. But a little bit every day goes much further than trying to cram and do a bunch in one day. It's just kind of like working out. You would never go to the gym for 6 hours. At least I hope you wouldn't, right?
Right. Please don't.
But you will never go to the gym for 6 hours and do a 6-hour workout. You will go and do a 30-minute workout, an hour workout, an hour and a half a workout. But a little bit every day is so much better.
And I put up on the screen a sample GMAT study plan that Stephanie's put together. This is a 31-day plan, so this assumes that you've picked your date and you've got a month of prep. And you'll notice there's a little something on every day. She even outlines the dates. We're going to take a day off. We're going to relax. We're going to, because you're not going to go to the gym every day, again, we hope. You're going to go and you're going to have those days off to recover. So making sure you're looking at those practice test days and the specifics of what you're going to be doing each day.
Exactly.
That's great.
Exactly. And then if you have some downtime while you're sitting in the doctor's office, or while you're waiting in line at Publix or Kroger, or anytime you get 5-10 minutes here and there, again, pull out some flashcards. If you're on Facebook or Twitter, you can go like the MathSP page. I post questions on there every day, so you can practice some of those questions from your phone, or if you have some downtime at home from your computer. Those are 2 great resources with lots of other problems that you can solve, and there's all kinds of competitions and things on those pages where you can get involved and really have other people to kind of challenge each other a little bit in a very fun way, of course. So those are really great resources, and also ways that you can reach me and ask me questions about how everything's going for you in terms of your GMAT prep.
And I put up on the screen a great opportunity and offering from Stephanie that she's doing for just those of us that are listening and viewing the chat today. She does small group courses, so a little bit more like this, but in a smaller group setting. And the next one begins on Thursday, March 6th. So that's perfect for those of you who are trying to get that test in that April and May timing, and you want to make sure you have some training and some prep beforehand. You've watched this, and you're realizing now sort of the amount of work you want to put into it beforehand, because definitely as much as you put into it is going to be reflected in what comes out at the end of that exam. So the features of the small group course, the GMAT ladder course she has there, are up there on the screen. I'll let her talk through it, but if you'll notice, she offers a registration code. If you register by this upcoming Monday, you'll save $100 on the ability to take that class, which is huge, and just is sort of an investment in your plans long term for making sure this test turns out the way you're expecting it.
Right, exactly. And this is a great time to come and to work through these official guide problems together. What we'll do together is pound through problem after problem after problem after problem. We'll review all those key math concepts that were outlined in the beginning of the presentation. We'll make sure that you're refreshed and brushed up on exponent rules and prime integers and factorization and multiples and all the different ins and outs you need to know for the test. There is a limit to 10 students per course, and I think the course is half full at this point, so we have space for, I think, 5 more students as of this morning before I came here. So if you're interested in the course, definitely register by Monday. You'll get that discount before, up until Monday evening. If you have questions about the course, feel free to email or call. It meets on the Emory campus, so if you're local and Emory is close to you, then this is a great opportunity for you to come to the campus and, network and be with other students who are also interested in the program here, as well as on the same sort of in a study group with other people preparing for this GMAT, so that you have people to work with and support you through the process.
And I know I remember it being very integral when I took my test, to just have people to bounce it off of, or test questions and just talk things out. Right. Because it kind of gets you in that mindset for longer than just the little bit of time you're studying.
Exactly.
You'll see on the screen Stephanie's contact information. Again, you'll get this deck and a copy of the actual video presentation that went today about 5 or 7 days from now. That way you can have that. But definitely write down her contact information now, should you be interested, since that will be after the Monday, March 3rd registration date. So make sure you write that down. Her information here, website, phone number. Follow her on Facebook and Twitter. Again, as she mentioned, having those questions out there to just look at every day just gets your mind in the frame of mind to be ready for test taking, and that's very helpful. It's also very helpful because that's a state of mind you're going to be in when you start a business school, right? The test is great to determine your skills, but it's also a good way to get you ready for that kind of continual learning and thought process that you're going to use during your time in a program. So I'd like to thank Stephanie for her time here with us today. I want to thank you guys for joining us. Again, we'll have, for all of the registrants from today, you'll receive the slides and the video itself in about 5 to 7 business days, but write down the information on your screen. Stephanie Espy, if you're interested in doing her GMAT prep small group courses that, again, meet here on Emory's campus. We'd love to see you here. I know Stephanie would love to have you in her group, and we hope you have a great rest of your day.
Thank you.